Okay, so in this video I'm having a look at another type of symmetry in the unit circle type of question. So this is one where we've been given a circle, we've got a few things put on our circle. So we've got a point on the circle where we've got our line drawn, we've got theta, and we've been given these coordinates. Now they then help us to work out some of the things for our trig ratios. So we know that we have that cos theta equals adjacent over hypotenuse, sine theta equals opposite over hypotenuse, and tan theta equals opposite over adjacent. Now, obviously, if we've got the unit circle, the hypotenuse is 1. So if we've got the adjacent over hypotenuse, when we're talking about the adjacent side, that's our x coordinate, and it's being divided by our hypotenuse, which is 1. So basically, we've just got for cos theta, we're looking for our x coordinate. For sine theta, our opposite is that vertical line, so that's going to be our y coordinate. And we're dividing that by 1, so same like our cos. And then when we've got opposite over adjacent, that's going to be our opposite will be our y over x. So we can then go through and work out some things. We're going to use some symmetry, because if we've got our orange line over here, we know it's going to have the same coordinates, but we also know that there's going to be some sign changes, as in positive and negative. So we've got this one over here. If we've gone into the negatives with our x value is still going to be a half, but it's going to be negative a half. But our y is still positive because it's still above the x-axis. So we've got negative a half and root 3 on 2. Over here with our blue line, we can see that our x remained the same. So we've got our half stayed the same, but now we've got negative root 3 on 2 for our y coordinate. I realise those are a little bit fuzzy, those numbers, but hopefully that makes sense. So then we can work through some things here. So if we've got cos of pi minus theta, so that's what we've drawn in here, pi minus theta. So we've gone around and back theta, so to get to that orange line. If we're looking at cos of that, we know that's going to be our x value, but in this case our x value is negative, so we get negative a half. Now, if we went back to our understanding of our symmetry, we also would have known it was going to be negative because of our CAST. So we know that in that quadrant that cos is going to be negative, and it would be the negative of whatever it would have been in the first quadrant. And because we knew it was going to be the half over 1, which is a half, we can say then it will be negative a half for the one in the second quadrant there. When we've got sine of pi minus theta, this time our sine is positive, so we can just say it's going to be that root 3 on 2, because we're looking at that y value, off the screen, our y value there of root 3 on 2, and it is positive because we know in that quadrant sine is positive, but we also can see that the y coordinate is positive. So this set of questions really is trying to link together those concepts of what quadrant you are in the unit circle, the symmetry, and why it works out that way. If we've got cos of negative theta, that means we've gone back theta, and that's we're now looking at our blue line. Our cos is looking at the x value, and in that case, it's going to be the half that we wrote down there. So by putting in the coordinates, you can easily find out what the value is, but we can also come to that understanding as well, because we know in that quadrant cos is positive. So that's why this is a bit of a linking question that's bringing together those two concepts. However, when we look at sine of negative theta, in that quadrant sine is negative, so we would expect our answer to be negative, and when we look at our y coordinate, it's going to be negative root 3 on 2. Then when we get into our tan, that's where we're looking at our opposite over adjacent. So when we're looking at the one of pi minus theta, it's up here. So our opposite over adjacent is going to be our y over x. So we've got root 3 on 2 divided by negative a half. When we divide by negative a half, it's the same as multiplying by 2. So we end up with negative root 3. And then for our negative theta, we've got our, and so in that quadrant, for part E, we know that tan was going to be negative, so we expected a negative answer. Then when we've got it down here, we would be expecting a negative as well. So we've got, in this case, we've got our negative root 3 on 2 divided by positive a half this time. So that will come out to negative root 3 again as well. So that's how you can work through that, but also use your knowledge of your quadrants and what you're expecting them to be in those quadrants as well, and linking to your trig ratios of cos theta adjacent over hypotenuse, sine theta opposite over hypotenuse, and our tan theta of opposite over adjacent. So it's bringing all those concepts together.